Have you ever pondered the mysteries of our vast universe? What forces are at play, shaping the cosmos as we know it? Dive with me into the cosmic ocean, where we'll surf the waves of mystery and wonder that continually shape our understanding of the universe. As we embark on this journey, we'll explore the enigmas that have puzzled humankind for centuries, and the solutions that have been pieced together by the brightest minds in our history. Think about the universe as an ever-expanding canvas, painted with stars, galaxies, and nebulae, splashed with the colors of cosmic radiation. It's a vast, infinite expanse that stretches well beyond our imagination. But what paints this cosmic canvas? What mysterious brushstrokes determine the shape, size, and movement of the galaxies we see in the night sky? The answers lie in the forces that govern the universe. Gravity, electromagnetism, the strong and weak nuclear forces, these are the artists of our cosmic canvas. Together, they shape the universe and everything within it, from the smallest particles to the largest galaxies. Yet even with these forces, there are still mysteries that elude us. There are phenomena that our current understanding can't fully explain. For instance, why is the universe not just expanding, but accelerating in its expansion? What force could be driving this acceleration, overcoming the gravitational pull of all the galaxies? These questions have led scientists to hypothesize about a mysterious unseen force. A force that doesn't just shape the universe, but dominates it. A force that is so elusive, we can't directly observe it. We only know it exists because of its profound effects on the universe. This force, my friends, is what we call dark energy. It's the unseen artist, adding its own strokes to the cosmic canvas. It's the enigma that has both baffled and fascinated scientists, driving them to delve deeper into the mysteries of the universe. One such mystery, perhaps the most profound of all, is the enigma of dark energy. What is dark energy, you may ask? It's something that has puzzled scientists for decades. Imagine a force, a mysterious entity, that's invisible yet omnipresent, silent yet powerful. This is dark energy, an intimate part of our universe, yet something we know so little about. It's like the silent whispers of the cosmos, heard only by those who dare to listen. Dark energy, in its simplest definition, is a type of energy that exists throughout all of space. It's not something you can touch or see, but it's there, woven into the very fabric of our universe. It's a cosmic antithesis to gravity. Where gravity pulls, dark energy pushes. This push is not just random or arbitrary. It's a cosmic acceleration, a force that's driving the galaxies apart, making the universe expand at an ever-increasing rate. The universe, you see, is not a static entity. It's dynamic, it's evolving, it's expanding. And dark energy is the enigmatic conductor of this cosmic symphony. But where does dark energy come from? That's a question that's been haunting the corridors of cosmology for quite some time. Some theories suggest it's a property of space itself. Just as a fish is unaware of the water it swims in, we're unaware of the dark energy that surrounds us. It's the energy of the vacuum, the energy of nothingness. Other theories propose that it could be a new form of energy field, something not yet discovered. Or perhaps it's a fundamental cosmic constant, an integral part of our universe's blueprint. The truth is, we don't know for sure. It's one of the biggest mysteries in modern physics. But we do know this. Dark energy is not just a minor player in the cosmic stage. It's the majority shareholder, accounting for around 70% of the total energy in the universe. That's right, most of the universe is made up of something we can't even see or touch. Dark energy, an entity as enigmatic as it sounds, is a force that permeates all of space and accelerates the universe's expansion. The discovery of dark energy was one of the most surprising revelations in the late 20th century. It was a shocker, a twist in our cosmic tale that left scientists grappling with an entirely new concept. It all began when astronomers were observing distant supernovae. These celestial explosions serve as cosmic mile markers, helping us measure distances in the vast universe. The expectation was that the universe's expansion, kick-started by the Big Bang, would be slowing down due to the gravitational pull of all the matter within it. However, The observations painted a different picture. The distant supernovae were dimmer than they should have been, indicating they were farther away than anticipated. This suggested that not only was the universe expanding, but this expansion was accelerating. It was like throwing a ball into the air, and instead of it slowing down and falling back, it sped up into the sky. It defied our understanding of gravity. So what could be causing this? Scientists proposed an unseen, unknown form of energy was at work, pushing galaxies apart. They called it dark energy. Dark because it does not emit or absorb light, and energy because it's causing the universe to expand at an ever-increasing rate. When this idea was first presented, it was met with a mix of astonishment and skepticism in the scientific community. It seemed too extraordinary, too outlandish. Yet, as more data rolled in, the evidence for dark energy became too compelling to ignore. In 1998, two teams of astronomers, the Supernova Cosmology Project and the High-Z Supernova Search Team, independently announced the discovery of dark energy. Their findings were based on observations of dozens of distant supernovae, and it was a game-changer. In 1998, the world came to know about this mystifying force, a discovery that not only surprised, but also challenged our understanding of the universe. Today, dark energy remains one of the biggest mysteries in cosmology, a testament to the intriguing complexities of our universe. How much dark energy resides in our universe? The answer might astonish you. Imagine a pie, a cosmic pie if you will. If we were to slice this pie into sections representing the different components of our universe, dark energy would take up the largest chunk. Quite a hefty chunk indeed, making up about 68% of the pie. That's right, more than 2/3 of our universe is composed of this elusive yet dominant force known as dark energy. So, how do scientists arrive at this staggering figure? Well, it's all about observing the universe's expansion. The universe is not just expanding, it's accelerating in its expansion. This acceleration can't be explained by the matter we see, the stars, galaxies, and even the elusive dark matter. No, there needs to be something else driving this acceleration. And that something else is what we call dark energy. Now, it's important to remember that these are estimates. Scientists are still grappling to understand the nature of dark energy. But every observation, every calculation, every piece of evidence we have points to this. Dark energy is the dominant force in our universe. You might be wondering, if dark energy is so abundant, why don't we see it? Why doesn't it affect our daily lives? The answer is simple, yet profound. Dark energy doesn't interact with matter in the way that other forces do. It doesn't pull objects together like gravity, or cause them to repel like electromagnetism. Instead, it's a force that works on the grandest of scales, influencing the shape and fate of the universe itself. So the next time you gaze up at the night sky, consider this. Behind those twinkling stars, between the galaxies, filling the vast expanses of space, is a force so powerful, so dominant, that it shapes the cosmos itself. A force that, despite its invisibility to our eyes, holds sway over everything we see and don't see. Yes, you heard it right. Dark energy, this mysterious force, makes up more than 2/3 of our universe. What about our home, the Milky Way? How does dark energy influence our galaxy? You see, it's not just the space between galaxies that's expanding due to dark energy, but also the space within them. However, the effects of dark energy are not as noticeable within galaxies like our Milky Way because the force of gravity is stronger at such relatively short distances. Dark energy plays a pivotal role in the formation and evolution of galaxies, including our own. When galaxies began forming approximately 13 billion years ago, the universe was much smaller and gravity had the upper hand. Over time, as the universe expanded, dark energy began to dominate, causing the rate of expansion to accelerate and limiting the growth of galaxy clusters. But let's not forget, the Milky Way is not a stagnant entity. It's a dynamic, evolving system. Over its lifetime, it has undergone and continues to undergo a series of transformations, influenced by both its own internal processes and the cosmic environment. Dark energy, with its repulsive force, plays a significant part in these processes by driving the universe's accelerated expansion and influencing the galaxy's interactions with its cosmic surroundings. Even though we can't see dark energy, we can observe its effects. It's like the wind. We can't see it directly, but we can see the leaves rustling and feel its touch on our skin. Similarly, we observe dark energy's influence through its impact on the universe's structure and the motion of galaxies. It's the unseen force, the silent director of the cosmic drama playing out on the grandest of scales. So next time you gaze up at the starry sky, remember that what you see is just a tiny part of the grand cosmic ballet, choreographed not just by the visible stars and galaxies, but also by the mysterious and elusive dark energy. Indeed, dark energy, the invisible puppeteer, is constantly shaping and directing the cosmic ballet of our galaxy and beyond.